Yeah, Ursha, baby. This is for the.
First come, first served scheduling. Other names of its algorithm are first in, first out. Run to completion. Run until done. Perhaps first come, first served algorithm is the simplest scheduling algorithm. Processes are dispatched according to their arrival time on the ready queue. Being a non-preemptive discipline, once a process has a CPU, it runs to completion. The first come first served scheduling is fair in the formal sense of human sense of fairness, but it is unfair in the sense of long jobs make short jobs wait, and important jobs make important jobs wait. First come first served is more predictable than most of other schemes.
Everyone, my name is Guzman. I'm here to help you in solving a first come first served scheduling problem. As you can see, there are 5 processes arrive at a different arrival time and has a different burst time. In the process 1, it arrives at a time of 0 seconds and has a burst time of 5 seconds. As you can see, there are 5 processes arrive at a different time and has a different burst time. On the first process, it arrives at a time of 0 seconds. To do here, the arrival time of the process 1, which is 0 seconds. So I'm going to put here 0 seconds on the left corner of the first process, and had a burst time of 5 seconds. The process 2 has a burst time of 3 seconds. Process 3 has a burst time of 3 seconds, and process 2 has a burst time of 3 seconds, which means that 3 seconds will be added to the burst time of the process 2. So it'll be 8. Now the process 3. Process 3 had a burst time of 2 seconds. And what we have here is 8. So we're just going to add it. 8 plus 2 is 10. Now, let's move on to the process 4. Process 4 had a burst time of 4 seconds. So 10 plus 4 is 14. Lastly, the process number 5. Process number 5 had a burst time at a time of 0 seconds. Process 3 arrived at a time of 4 seconds. Process 4 arrived at a time of 6 seconds. And lastly, the process 5, which is arrived at a time of 7 seconds. Each of the processes had a different burst time. Process 1 have a burst time of 5 seconds. Process 2 have a burst time of 3 seconds. Process 3 had a burst time of 2 seconds. Process 4 had a burst time of 4 seconds. And lastly, the process 5 had a burst time of 1 second. Now, in solving this, we have to make a Gantt chart. As you can see, I've already done here a Gantt chart. Contains each of the process from 1 to 5. I'm going to do here the arrival time of the process 1, which is 0 seconds. So I'm going to put here 0 seconds on the left corner of the first process, and had a burst time of 5 seconds. The process 2 has a burst time of 3 seconds. Process 3 has a burst time of 3 seconds, and process 2 has a burst time of 3 seconds, which means that 3 seconds will be added to the burst time of the process 2. So it'll be 8. Now the process 3. To the gun chart, we're going to do the schedule time. In getting it, we need the gun chart. So if you're wondering what is schedule time is the time when did you started each of the process. So let's go back to the gun chart. So we started a process 1 at a time of 0 seconds. I'm just going to put here 0. Process 2 started at a time of 5 seconds. 5 seconds another here, and process 3 started at a time of 8 seconds. Just some 8 here. Let's move on to the process 4. Process 4 started at a time of 10 seconds. Just another 10. And lastly, process number 5, which is started at a time of 14 seconds. Another here. There you go. We're done in the schedule time. Now let's move on to the completion time. What is completion time? Anyway, completion time is the time when you finish each of the process. So let's see here. When you finish the process 1, we finish the process 1 at the time of 5 seconds. Let's move on to the process 2, which is finished at a time of 8 seconds. 8, and we're going to process 3. Process 3 is finished at a time of 10 seconds. So 10 in here, and let's move on to the process 4. Process 4 is done at a time of 14 seconds. Just going to put 14 here, and lastly, the process number 5. Process number 5 is done at a time of 15 seconds. So 15 seconds, and there you go. Completion time is done. So we're done to the completion time. Let's move on to the turnaround time. Turnaround time is the time where all the process is all done. Anyway, there's a formula in getting a turnaround time. I'm just going to write it down here. Put the turnaround time is equals to completion time minus arrival time. If I'm not, yes, it is arrival time. Yes, it is arrival time. I'm sorry about that. Anyway, let's move on again. There you go. What is the completion time of process number 1? Completion time of process number 1. It's obviously 5, and it arrived at a time of 0 seconds. So 5 minus 0 is 5. Process number 2 had a scheduled completion time of 8 seconds and arrived at a time of 2 seconds. So 8 minus 2 is 6. Process number 3. Process number 3 had a completion time of 10 seconds and it arrived at a time of 4 seconds. So 10 minus 4 is 6. Next, the process number 4. Process number 4 had a completion time of 14 seconds and arrived at a time of 6 seconds. So 14 minus 6 is 8. Just going to put 8 here, and there you go. And lastly, the process number 5, which has had a completion time of 15 seconds and arrived at a time of 7 seconds. 15 minus 7 is 8. And done. we're done to turnaround time. And now let's move on to the last chapter of it, the waiting time. So in solving the waiting time, there's a formula. In solving it, which I'm going to write here, down here, waiting time is equals to turnaround time. Anyway, TAT stands for turnaround time minus burst time. And we're done. So we're just going to do it. Process number 1 has a turnaround time of 5 seconds and had a burst time of 5 seconds.
Hey guys, so I'm Marvin Galeos and I'm here to report about OS, the first come first serve, and also the shortest job first serve, preemptive and non-preemptive. So, okay guys, this is shortest job first serve, non-preemptive. So I only have 5 processes because this one is a little bit difficult. So I'm just going to do 5 processes. So I'm gonna be finished easily. Uh, Again, we have TAT and WT. So this is how to solve it.
Hi everyone, I am Carmela de Guzman at your service.
Hey guys, so my name is Marvin Galeos.
Yeah, Ursha, baby. This is for the